Element X has a lattice of positive ions and a sea of electrons. So you're showing a metal. Which property will X have? It conducts electricity by the movement of ions and electrons. That's almost true, but ions. It won't move any of its ions. They're fixed in positions, but it will move electrons. So the statement is wrong. It has a high melting point. Well, yeah, kinda. There are exceptions, but metals will generally have a higher melting point. I'll put this on hold. Let's come back to it at the end. It decomposes by an electrical current. Well, that's the exact opposite of what a metal is, because metals can easily conduct electricity and not decompose. And we haven't really seen any compounds, by the way, which decompose on electricity, and we'll see those. So this is wrong. This is wrong. It is not malleable. Well, exact opposite, where this is malleable. Why did I use blue for the last one? It is malleable. So the answer, the most likely contender, even though I'm not a fan of it because mercury is a liquid at room temperature, the most likely answer out of the four is B. The answer is B. Sodium and magnesium are next to each other in the periodic table, where their melting point and boiling point are highlighted. Which statement explains the difference in melting and boiling points? What could explain it? What is a melting point? When a solid changes states from, like when a solid turns into a liquid, right? Changes its state. What allows this to happen? Well, the bonds aren't strong enough, or like whatever's holding them together, they're not strong enough anymore compared to their own vibrations and their own kinetic energy, right? That's what a change of state is. That is what melting is. So why could this be so stronger in magnesium than in sodium? Let's check the answers. Sodium and magnesium have different types of bonding. That's not true. They're both metals. They both have this very similar kind of bonding. Exactly the same even. Electrostatic forces of attraction are stronger in magnesium. That's like word for word trying to explain exactly what's going on. So I don't even want to read what's next. I'm confident the answer is B. Let's take a look at C. The ionic bonds in magnesium are stronger than those in sodium. That could be true as well if this was an ionic compound, but we're talking about metals, not their ionic compounds. Metals will bond with different non-metals to form ionic compounds, whereas they themselves are metallic. That's why they're called metals. So C is wrong. The magnesium atoms are larger than the sodium atoms. Yeah, I'm trying to remember if they are larger. I think they're not larger. Yeah, I think they're not larger. But it doesn't matter because it's inconsequential anyway, even if they are or not, because we never talked about the size of the atom or the ion. So they could have just said magnesium is a happier atom, but what's that got to do with it? We never talked about size, right? So it's just as inconsequential. B is our answer. We were confident with B, we'll stick with B. Which solid can layers of atoms slide over each other? I mean, graphite, do I even need to? But not in diamond, they're all covalently bonded. Graphite, yeah, graphite. Hematite, we don't even know what that is. It's an iron ore. We'll see this when we do metals next year. Silica, that's sand. Nope. So, graphite, that's an easy question. Complete recall based question. No logic required. Let's move on. Which structure is that of an alloy? An alloy is something where two metals are mixed together and they're allowed to turn into a solid. So, key, we have two different positive ions, negative. You won't have negative ions in an alloy, so they're trying to confuse you with the key even. How dare they? And you have electrons. I mean, it's a mixture of metals. Both metals will just be positive ions with electrons around them. There's no such thing as a negative ion for metals. I mean, there can be, but like we never see it. Okay. This is not an alloy. This is a pure metal. How do I know? They're the same ions. It's not a mixture. Over here, it's the same ions again, but they're all messed up. So it's a bad metal, I guess. I don't know. Over here, hey, mixture. Yep, this looks all right. Over here, there's no negative ions, so C is our answer. Let's move on. Yes, our first challenging question. All right, you guys should spend a good amount of time trying to do this question, and if you can't figure it out, even then watch the answer. But this is a good question, I like it. Which substance has metallic bonding? So C and D are out. As both solids and liquids, they'll conduct. Okay. So let's cancel out C and D by crossing them out like that, scratching them out. Okay. So they'll both conduct. State of product formed on reaction with an oxide, solid or gas. So if you have a metal reacting with oxygen to form an oxide, so you have a metal, it could be a plus ion, it could be a 2 plus ion, it could be a 3 plus ion, and that could react with oxygen to form, well, this is going to be MO, metal being some unknown metal. It could be M2O, and it could be M2O3. Yeah, right. TK. What kind of compounds are these? They're all ionic. If they're ionic, will their product be gaseous or solid? Only one answer here. It's going to be a solid for sure, because ionic bonds are held together by ionic bonds, which are very strong. A is our answer. A. Brass is an alloy. Which statement about brass is correct? It contains a sea of electrons. Yes. It's still a mixture of two metals. They're on there. But I'm not too happy with this particular answer. I'll go on. I'll read more. A is not the best thing you can talk about brass. So it's still true. It still will conduct electricity. And it does. It contains positive ions and negative ions which are free to move. It does not conduct. What's with negative ions and alloys? It does not have negative ions. So B is wrong. This is like I live in a firefight zone. It is a compound of a metal and a non-metal. No, alloys are two metals mixed together. It is a compound of two or more metals. Yes, I almost thought this was it, but it's not a compound. It's a mixture. Worst M I ever wrote in my life. It's a mixture, right? It's not a compound. So the answer, we go to A. The list shows some substances that conduct electricity. Aqueous sodium chloride. Yes, because ionic form metal conduct electricity. Copper conducts, graphite conducts. In which of the substances are only electrons involved in the conduction? Well, that's copper and graphite. And that's our only multiple choice answer. Answer is B. A metal consists of a lattice of positive ions in a sea of electrons. I think by the end of this, I'll be tired of sea of electrons. Like, I'll be done. What happens to the electrons? I think we'll be done, but okay. What happens to the electrons and positive ions in a metal wire when electric current is passed through it? Electrons are replaced by new electrons. So that makes sense because more electrons are flowing through it. Let's try drawing a metal, part of a metal with positive ions. And if electricity is flowing through it, more electrons are flowing into it. So these electrons get pushed ahead. And so it's kind of like they do flow through it, right? And so that makes sense. Replaced by newer electrons, replaced by newer ions is a big no-no because ions will stay the same. Replaced by newer electrons and are unchanged. Why am I scratching that out? I like that. Replaced by newer electrons and positive ions are unchanged, where C and D are already out because they're talking about it being unchanged. So So our answer is B. In the ionic solid zinc phosphide, what is the formula of the phosphide ion? All right, so zinc has a charge of 2 plus, and the charge on phosphide ion is our unknown, which is X. But their sum of charges is equal to 0, and you have 2 phosphide ions, each with a charge X, and you have 3 zinc ions, each with a charge 2. I should have left some space, but adding all of these together, it should be 0. And X turns out to be negative 3, I think. Yeah, negative 3. So the answer is A, right? And at this point in time, how do I know the charge on zinc ion? Because it's not in group 1, it's not in group 2, it's a transition element. This is one question which will be more equipped to answer once we end up doing metals or some other chapters. But right now I wouldn't ask people to know what this is. So questions like this won't really show up immediately. We'll see these questions next year. So don't worry too much about this showing up, right? I just like the calculation over here. So I showed it. You can answer the same question if it was talking about phosphorus, and over here they had something like aluminum or magnesium over here. So good question to look at. But don't expect this question to show up in your test or exams. Which statement about graphite is not correct? I love these not correct questions because I always get them wrong because I'm always going for the correct answer. I'm a perfectionist, and that's my biggest, what's a good term for my biggest? Weakness, I guess. It burns to form carbon dioxide. Graphite, does it? Doesn't carbon do that? Doesn't carbon burn, react with oxygen to form carbon dioxide? Graphite is carbon, and it will do that. It is a carbon compound. Well, you could say that, but it is carbon. It's not a compound of carbon. It's an element. It's a carbon element. It's not a compound. So B is out. And I guess that's our answer. But let's go through exhauster list. It is a giant molecular structure. It is used as a lubricant. Oh my god. They're not too creative, are they? It's the same thing. Graphite, if they ask about graphite, it's always about it is carbon. It's always about the lubricant. And the answer is B, unceremoniously. Which diagram shows the structure of an alloy? Again, alloys are a mixture of two different metals. And what could be it? And even if you didn't know it, I think, because we barely covered alloy in our classes, alloy is something new. You know what B is, right? You know what B is, you know what C is, you know what D is. So A has to be an answer for this question, right? Because B isn't an alloy, C isn't an alloy, D isn't an alloy. What are they? C is graphite, where C is an ionic compound, and D is some metal without the electrons shown. A is your alloy, where you have different sized ions present over here. Which statement shows that graphite and diamond are different forms of the element of carbon? Both graphite and diamond have giant molecular structures, but that doesn't show me that they're the same carbon. I know that, but it doesn't show it to me. Complete combustion of equal masses of graphite and diamond produce equal masses of carbon dioxide and no other products. Yeah. This is one thing I found it very interesting, but I thought I didn't talk about in class. So what they did was they measured some graphite. I don't know how to draw graphite. And they measured it, so they made sure it was the same mass. So if it's the same mass, it's the same amount of carbon, then let's say a same mass of diamond. I know how to draw diamonds, right? And they reacted it with oxygen, and they collected the amount of carbon dioxide that's formed, And they weighed it and they realized, I don't know how much carbon dioxide will form. If I can do the calculation, but let's say 40 grams was formed, right? They did the same thing for diamond and it was 10 grams, and they reacted it with oxygen, and diamond, like, you know it burns, right? Shocking, right? And it would burn. And it's shocking, yeah. I was just as surprised when I heard it the first time. But diamond, because it's made of carbon, it's slightly harder to burn it, because carbon doesn't really want to do anything as it's tightly connected with those covalent bonds. But when it did burn, it would produce the same amount of gas. Let's say if it made 40 grams the first time, it ended up making 40 grams. So we're confident B is the answer, but let's exhaust our options. Graphite and diamond have different melting points. Graphite and diamond, that doesn't tell me anything. They could be different products if they have different melting points. That's actually telling me they're different products. Like, that's my intuition. Because when was the last time you heard someone compare, graphite and diamond as the same thing? You just never hear it. And it's a shock for people to find out that it's the same thing. Oh well. Graphite conducts electricity, whereas diamond does not. Again, that tells me they're different, not the same. So B is our answer. And I'll write B just to affirm it. Copper wire is used to complete an electrical circuit. What happens to the copper wire? Do electrons move along the wire to the negative terminal? Positive ions stay in position? Well, they don't. This is a physics question, is it? They don't go to the negative terminal, they go to the positive terminal. Electrons come from the negative terminal to the positive terminal. I apologize on behalf of CAIE of this question, because they don't know what chemistry is, apparently. Well, this is turning into a physics question. I'm joking. Electrons move along the wire to the positive terminal. Positive ions move to the what? I'm surprised they're saying positive ions. They could have just said protons at this point, which they'd be just as strong because of the amount of wrong answers, wrong things they come up with. Electrons move along the wire to the positive terminal. Yes. Positive ions stay in position. C is our answer. I'm not even going to dignify D with my attention. Let's move on. Tables. I love tables. Table gives the melting points, densities, and electrical conductivities of 4 elements. Let me ask you guys this. Do I look like a guy who likes tables? Which element is copper? Copper has a melting point of reasonably high. I'm going to say it's D because it's just the odd one out over here. I'm going to say just D. And if I think about it, copper, where is copper used? Copper's strictly used for like a really good, you've seen copper, I'm sure some pots and pans are copper made and some piping are copper made, but it's mostly used as wires because it's a really good conductor of electricity, right? And I don't know, when was the last time anyone saw copper melt? So it's not gonna melt at the same temperature as, like, lower than the temperature than water boils. So I think this was a sign sent from God that D is our answer. So I'm just confident with D. But let's argue densities as well. Wow, this is a true anomaly. This is a gas at room temperature. No, it's a liquid because it melts. I got confused. But yeah, that's why it looked like an anomaly. So this is probably a liquid metal. This is mercury or something. It's so dense and a liquid at room temperature, possibly. Could be a gas, but definitely, how could it be a gas? It's so dense. A liquid. And this is probably, very likely, mercury. I'm guessing it's mercury. Right? Okay, anyway, I'm just fascinated with this little combination of stats. Let's move on. We have brass, ladies and gentlemen. Brass is harder than pure copper because zinc atoms form strong covalent bonds Metals do not form covalent bonds. The zinc atoms prevent layers of copper atoms from sliding over each other. Yes. Yes. This layer cannot slide over the... Yes. This is it. I think A just defeated me. It's too late at night and this option defeated me. Broke me as a person. The zinc atoms prevent the sea of electrons has nothing to do with its own malleability. It helps it, but it's probably gonna prevent it's gonna prevent electricity from conducting it. So if it was electricity, it just never happens. So no point talking about it. C is incorrect as well. A is incorrect. Zinc atoms have more electrons than copper atoms. That may be true, it does look bigger, but what's that got to do with anything? B is a very on-point answer. If you thought I was joking about the previous answer breaking me, that previous question, it did. I am defeated. Compound Z is made from element X and element Y. It's a compound. Compound Z is a good conductor. So that Z is the metal over here. We're talking about the metal over here. Z is the metal, whereas Y is the... Oh, I'm sorry. Z is the compound, and it's ionic because it conducts well. I just, while writing metal, I read the next part. So it doesn't conduct electricity as solid, but so I thought Z was one of these guys. Z is an ionic compound. This statement is correct. Compound Z has strong forces of attraction between electrons and positive ions. Oh, that sounds like a metal. So that sounds Z for you. Compound Z has strong forces of attraction between negative ions and positive ions. Yep. Can't say that enough. Element X and Y are both metals. Yes, but no. Mostly no. That's incorrect. Element X and Y are both nonmetals. That would make it covalent, and metals do not react. They'll at worst form alloys, which is just a mixture. So D is incorrect, C is incorrect, B is highly correct, whereas A is an incorrect statement as well. So the answer is B. Which diagram correctly shows the arrangement of ions in solid sodium chloride? A looks pretty good to me. They're alternating. Chlorine, next to chlorine, it's all sodiums. Next to this chlorine, it's all sodiums. Next to this sodium, it's all chlorine. I'm confident with A. This is an issue. Sodium cannot be next to a sodium. That makes no sense. B is wrong. Same issue with C and same issue with D. Sometimes these questions just really I find them condescending. Properties of 4 solid elements. Which element could be graphite? Electrical conductivity should be good, whereas melting point needs to be ridiculously high. It could be this guy as well, but hey, it does conduct electricity. So B is the answer. Diagram best represents structure of solid metal. Okay. A solid metal. How would you debate between C and B? And that's what I was looking at. Okay, it's not D because it's all around it. There's no electrons in the middle, which is fishy. So D is not it. A is not it. I know it's B. We've seen it. It's B. What's wrong with C? There's no good answer. It's just that these electrons seem to be locked. Whereas you'd probably see this because it's a sea of electrons, right? You're probably hearing this for the first time, I know. The electrons are a sea of electrons. That means they're just moving around. It's a torrent of electrons, a wave of electrons that keep on zipping around over here. It can be, so C is just not that, that's why C is wrong. Now, I'm more conflicted as to this. Knowing that C is wrong is probably poorly checking any chemistry or even physics understanding. It's probably testing how well you've memorized a picture like this. Oh well. But it's not A either because the ions are more or less regular as well, the positive ions. It's again a lattice, it's a repeating structure. This would be liquid iron, molten iron. Let's move on. B is the answer. I really am enjoying this graph. I'm really enjoying, like, it's so, if you try to understand it, it's so cool what they're trying to talk about. Oh well, let's try to process it. The graph gives the melting point of mixtures of lead and tin. So you start with pure lead over here and then percentage tin mixture. So when you have 100% tin mixture, that mixture is all tin. And this graph shows their boiling points. So if you have a bit of tin, it's slightly lower. And at this point, this is the surprising part, right? So pure tin will melt at 210, 220 degrees, where pure lead melts at 320, 310 degrees. But if you have a mixture at the right ratio, they'll both melt at, what is this, 80 degrees, 90 degrees, 95 degrees? That's so cool. That's so interesting. I mean, what, right? Like, just looking at this is so much information. Anyway, let's read the question. The graph shows that any mixture of lead and tin must have a melting point that is above that of tin, above that of lead, below that of both tin and lead, below that of tin and lead. What? The graph shows that any mixture of lead and tin must have a melting point that is below that of lead. Okay, yeah. I mean, such a cool. They've given such a interesting graph, and this is the question they ask. I feel too hurt to answer why exactly. Okay, I'll do it. That's my job. This is the melting point of lead. Any mixture of tin and lead is lower than the melting point of lead. Only lead, pure lead, is at the melting point of lead. Let's move on. Now, this is a really cool atom molecule. It's a Buckminster Fullerene. Now, some people might argue this is a macromolecule. You know who you are, right? Now, some people might argue that because look how big it is. How big is it? It's literally as big as 60 carbons. It's trying to mimic a football. You make this in the chemistry lab. This man-made. This is called a Buckminster Fullerene because Mr. Buck tried to make this, right? He made it. Didn't try. It's obviously there. How is the structure best described? Is it a covalent compound? Is it ionic, polymer, molecular? Well, covalent compound. Well, yeah, but it's molecular. I think by covalent compound, molecules are covalent compounds. But what it's trying to highlight, maybe it's a giant covalent compound. And because I saw this option, right? So it's technically, like, A is poorly phrased. I can read that. It's trying to ask if it's a giant covalent. This is like a blunder by CIE. But it's not ionic, it's not a polymer. We don't know what a polymer is yet. But it's definitely molecular. And why, you may ask, it's molecular is because, again, remember a mammal looks like a whale looks like a fish, has, fins, and like, how would you even argue that it's a mammal? But if you look at it closely with the scientific lens, it's a mammal because it breathes oxygen. It gives birth, and I don't know my fishes, so like it breathes oxygen is the number one thing, right? It has lungs. So it's more closer to a mammal than to a fish, even though it lives in water. This is more closer to a molecule than to a giant covalent compound. It's liquid at room temperature. It's a very thick liquid, but liquid nonetheless. It's a black liquid, right? And well, you didn't know this, but again, even in class, we were talking about a different polymer, and I gave examples of 100, 200, 300 atoms joined together, which will still behave as simple covalent molecules rather than giant covalent molecules. So again, this is a simple covalent compound or molecule, not really a compound. It's still elemental. And you could argue that this is also another allotrope of carbon. Remember what allotropes are? Allotropes are the same element existing in different forms. So this is over here we see carbon existing as a Buckminster Fullerene, where we've also seen it as graphite and as diamond. Carbon is single-handedly probably the most diverse atom that we generally have seen. Life is carbon-based, so you can get an idea of how complex carbon. You should, from here on forth, you should see carbon as Lego pieces. The carbon is the Lego of the atomic world, quite literally. We're all made of carbon because its ability to just bond in this dynamic way. Anyway, let's move on. What is the best conductor of electricity? It's magnesium, because it's a metal. No one else is a metal. Substance has a giant covalent structure and contains atoms of more than one element. Has a giant covalent structure and contains, sounds like sand. Huh. All right. All right. It is sand. Metals conduct electricity. The movement of which particles? Electrons. Come on. Come on. Which substance, when molten, conducts electricity? Ionic compounds. And these last few questions, I don't even have to read the answer. Only cesium iodide is a ionic compound. C and D are giant covalent, where A is a pure metal. It's a very beautiful metal. You guys should Google butamen. Butamen. B is our answer. Diagrams show the structure of two forms of carbon, one's diamond and graphite. Which X and Y conduct electricity? Well, Y does, and X does not, so C. I legit hate this question because I have to read 5 lines of text. And the first is, it had to be a sea of electrons. Okay. Metals are malleable because possible forces of ions slide over each other. Alloy, like brass, is blank malleable than pure copper, and then pure zinc, less malleable. And I'll tell you why. Brass is blank to conduct electricity. Unable to conduct electricity? It can, like, doesn't, what? That's unheard of. Any alloys of metals will conduct electricity because their parents can conduct electricity. So able, and it's less malleable, right? Because it's harder. And we saw that in a previous question. And that's because here's a structure of a alloy, right? You have different sized ions. So what happens is, okay, there are 2 sizes, even though I've drawn it properly. One's the smaller one, and these 3 are the large ones. If they're trying to bend or anything, these giant ions prevent these smaller ions from moving around too easily, and that reduces the general malleability or bendability or dentability of the thing. It makes it more harder or more closer to being brittle. And any imperfection does that to metals in general. The purer they are, the more malleable they are, because they're just smooth, regular lattices. and it's all about the lattice, their properties. Which statement is correct for all ionic compounds? They dissolve in water. Untrue. Calcium carbonate is one that does not dissolve in water. Marble people. They are formed when metals are electrons. They are shared their electrons with non-metals. Yeah. Yep. That's it. They conduct electricity in the molten state. That's also true. Wow. They conduct electricity in the sun. Well, D is wrong. I'm confident of that. They do not all dissolve in water. Let's take a closer look at B and C again. They are formed when metals share electrons with, sharing electrons. They donate their electrons to non-metals. Okay, I was about to lose my mark on a grammar issue, but okay, I guess they have a point. C is absolutely true. They will conduct electricity in a molten state. No trickery of grammar here. C is our answer. Which statement is correct of all metals? They are hard and brittle. Well, A is the answer, right? They are made up of lattice of positive and negative ions. They conduct electricity by movement of electrons. They conduct electricity by movement of ions. I do not... Questions like these are destroying me. They're too... What do you guys think of... Tell me, let me know, as vocal as you can be, in the comments probably. Let me know what you think of a question like this. I really don't like this question. I don't want to say too easy, but that's exactly, it's not challenging anything. It's just a poor question, I think. Let's move on anyway. In the solid state, germanium has the same structure as a diamond. Really? Germanium. I thought that was a metal. Okay, some germanium thing. Oh, it's gallium. I was thinking of gallium. Germanium has the same structure as diamond, so it walks, talks, and acts like diamond. What is the most likely temperature boiling point of germanium? Above 800? I think so. Between 100 and 800? I think not. 100 degrees Celsius? Yeah, it's going to act like water because below... Okay, it's got to be way higher than even 800. So A is our answer. Why again? Because diamond has an insanely high melting temperature. That's why germanium will have it, because its structure is similar to diamond.